In this video, I'll explain the IPAdapter ControlNet and KSampler components of the ComfyUI workflow and what it does. Let's get started. 1. IPAdapter Model Loader. This node loads the IPAdapter model, which is used for tasks like style transfer. It prepares the model and outputs it for the image generation pipeline. 2. Clip Vision Loader. This node loads a model called Clip Vision. It helps the system understand and process images. It generates an output called Clip Vision, which is used by other parts of the workflow. 3. IPAdapter Advanced. This is an advanced version of the IPAdapter. It processes images with additional control options, like adding style transfers. It takes several inputs such as the model, image, and clip vision data, and then outputs a processed model for further use. For the weight parameter, think of this as the strength dial for style transfer. If you want the style to be applied more strongly to the image, you increase the weight. For combine embeds parameter, this setting determines how embeddings, basically the learned features, are combined. If it's set to concat, the embeddings are combined by appending them together. For start at parameter, this is the starting point for when the IPAdapter starts applying the transformation. A value of 0 means it starts right at the beginning of the image processing. For end at parameter, this specifies when the IPAdapter stops applying the transformation. If you set it to 1, it will keep applying transformations until the very end of the process. For embed scaling parameter, this controls which embeddings get scaled. For instance, V only ensures that scaling applies only to vision embeddings, which are related to visual features. 4th, OpenPose Preprocessor. This node analyzes the image to detect key points, which are specific parts of the image that define poses, like joints or important features in a human figure. It then outputs both the processed image and the key points. 5. ControlNet Loader. The ControlNet model is loaded here. This model allows for more detailed control over the image generation process, such as guiding how the image should evolve. It outputs the ControlNet model, which is used in the next steps. For strength parameter, this adjusts how much influence the ControlNet has on the output image. A strength of 1 means the output will very closely follow the guidance data, like poses or edge maps. For start percent parameter, this is when ControlNet starts guiding the generation process. If it's set to 0, the guidance kicks in right at the beginning. For end percent parameter, this determines when ControlNet stops guiding the generation process. A value of 1 means it keeps influencing until the end. 6. ControlNet Apply Advanced. Once the ControlNet model is loaded, this node applies it to the image. It refines the output based on specific control parameters. The inputs for this node include the image, conditioning data, and the ControlNet model itself. 7. KSampler. This node is responsible for generating what we call a latent image. It does this by sampling the model with the conditioning data and noise. The result is a lower dimensional version of the final image. For seed parameter, this is like rolling a dice to get a random starting point for image generation. The same seed always produces the same result with identical settings, while different seeds create variations. For control after generate parameter, this decides whether ControlNet adds any influence after the image is generated. For example, choosing randomize adds some variation at this stage. For steps parameter, the number of steps controls how many times the model refines the image during denoising. More steps usually mean higher quality, but it will take more time. For CFG, classifier free guidance scale parameter, this setting balances how closely the output matches the positive prompt versus how much creative freedom it has. A higher value makes the output stick closer to the positive prompt. For sampler name parameter, this specifies the algorithm used for denoising during the sampling process. For example, DPM PSDE is a popular option for generating high-quality results. For scheduler parameter, this controls how the noise is progressively reduced during the generation process. Keras is a common scheduler for smooth and high-quality results. For denoise parameter, this adjusts the level of noise reduction. A value of 1 means complete denoising for clean results, while lower values keep some randomness in the output. See you next video.